Let's take a look at some principle of zero products examples. We want to try to solve some equations by factoring. The principle of zero products says that if I have a factored expression that's set equal to 0, I can set each of those factors equal to 0. There's a problem though. 30 is not equal to 0, so I need to do a little bit of work first. So a good first step, in order to solve an equation by factoring, you need to move everything to one side so that 0 is on the other side. So if I subtract 30 from both sides of the equation, I get a negative 30 on the other side there. And now what I'd like is this whole thing to be factored, right? So it's not, the way it's written here, it's not factored because, this part is factored, but it's not overall, the whole thing isn't factored. So I actually need to multiply it out first. I get x squared minus 13x minus 30. So factoring an expression, I have to be a little bit careful. The negative signs are important. 30 is of course 10 times 3, but because it's negative 30, I want one of those factors to be positive and the other one to be negative. So thinking of 10 times 3 as the factorization is kind of tempting because obviously 10 and 3 add up to 13, but they would have to have the same sign. They would have to both be negative to add up to negative 13. So the factorization that works with negative 30 is actually, if you think about the factors of 30, I want the factors to add up to a negative number, so the larger one has to be negative, and the factors that are going to work are going to be 2 and negative 15. Right? Those will add up to a negative 13 in the middle. So the factorization, it's going to be x plus 2 times x minus 15. And then the principle of zero products comes to our rescue to finish the problem. I know that one solution is going to come from setting x plus 2 equal to 0, and the other solution comes from setting x minus 15 equal to 0. So of course either x can equal 15 or x can equal negative 2. And we can check those. If we plug them back in, these two solutions, I should be able to plug them back into the original problem to check. And let's see. So if I plug in negative 2, I get negative 2 times negative 2 minus 13. And that's going to be negative 2 times negative 15. The negatives cancel when we multiply and we get a positive 30. So that checks. Plugging negative 2 in for x makes the left-hand side equal to 30. If I plug in 15, I get 15 times 15 minus 13. Of course, that becomes 15 times positive 2. And positive 15 times positive 2 is positive 30. So let's take a look at the problem y squared equals 9. To solve this with factoring, using the principle of zero products, I want to use the same first step. I want to subtract and get everything onto one side. So if I subtract 9 to the other side, now I have an expression, y squared minus 9, that hopefully I can factor, and we can because that's the difference of two squares. So this factors as y minus 3 times y plus 3. Since 9 is 3 times 3, negative 3 times positive 3 will give me a negative 9, and negative 3 times y and y times positive 3 will cancel out. And so we don't get a middle term that just has a y by itself. But of course now the principle of zero products makes it clear that one solution is going to come from y minus 3 equals 0. The other solution comes from y plus 3 equals 0. And so either y equals positive 3 or a second solution is y equals negative 3. Which makes a lot of sense because squaring a number will cancel out a negative value, and negative 3 squared is just as positive 3 squared is. Both of those, when we square them, become positive 9. I encourage you to pause the video for a moment and try to solve this equation using the principle of zero products. In a moment I'll work through the solution, but I encourage you to pause the video for just a moment and try to solve it on your own first. Well, I hope you took a moment to try to solve this equation. Let's see what we can do here. To use the principle of zero products, we need to set everything equal to 0. So if I if I subtract 3r from both sides, right? So if I want to try to get 0 on the right side, I can get the 3r with the 2r together, so that becomes r squared minus 5r equals 24, and then of course I can subtract 24 from both sides, so I get r squared minus 5r minus 24 equals 0, and now I want to try to factor this expression. So I want to find a pair of factors that multiplies to equal negative 24 and adds to equal negative 5. Negative 24, the bigger factor has to be negative. 3 and negative 8 are going to work. So this factors as r minus 8 times r plus 3. And so we get r minus 8 equals 0. We're setting that first factor equal to 0, which gives us a solution of r equals 8. And r plus 3 equals 0. If I set the second factor equal to 0, I get a solution of r equals negative 3. So we can check those two solutions. If I plug the 8 back in to the original equation, 8 squared is 64, minus 16 is 48. And on the other side, 24 plus 3 times 8 is also 48. If I plug in negative 3, I get 9 minus 2 times negative 3, so that becomes a plus 6. 9 plus 6 is 15. On the other side, I get 24 plus 3 times negative 3. 24 minus 9 is also 15. So these both work in the original equation, and those are our two solutions. I hope you enjoyed the video. Thanks for watching.